As soon as you hear the word teleportation, you're reminded of Star Trek and how fascinating it is to move from one point to another in the universe. Have you ever thought about the possibility of this becoming real? Teleportation has deeply marked the collective imagination, being a very recurring theme in science fiction works. Short stories, movies, and TV series have shown the potential, but also the dangers of this technology. In The Fly, for example, experiments on teleportation took a rather gloomy turn, and we could cite numerous other examples that stimulated curiosity and enthusiasm about the subject. The concept gained popularity in the 20th century, in the early days of science fiction literature. Authors such as Isaac Asimov and Philip K. Dick, in fact, play with the idea of moving instantly from one place to another, offering us exciting and disturbing visions of the future. In the film, teleportation is often depicted as a machine or platform. Characters enter and are dematerialized and then materialize elsewhere. Just these kinds of film representations have contributed to an almost magical view of teleportation. But is any of it real? How much of this fantasy is based on scientific reality, and how much is pure invention? Science fiction, let us point out, has great power. It takes quite complex scientific concepts and makes them accessible, often exaggerating or simplifying them for plot needs. However, it also has the power to inspire new ideas. Many of the modern technologies, tools we often take for granted, such as tablets or video calls, were once just fantasies projected on the big screen. And so, returning to our topic, is the teleportation we see in movies possible? Or is it just an illusion created to entertain us? Before we answer that, let's see what science says about it. And I guarantee you might be surprised. Let's leave movies and books behind and immerse ourselves in the universe of quantum mechanics. Here, the idea of teleportation is not fantasy, but a scientific reality. So let us try to understand what teleportation really means in this field. First of all, quantum mechanics is a branch of physics that studies the behavior of particles at the atomic and subatomic levels. Because of this, it gives us a completely different view of reality than the macroscopic world to which we are accustomed. Among the most extraordinary studies of this branch is the phenomenon of entanglement, also called quantum entanglement. What is it? Imagine two particles, which we will call A and B, being created together and sharing a special bond. Even if we separate them and move them miles apart, a change in A will have an immediate effect on B and vice versa. This instantaneous connection, which seems to defy the laws of classical physics and even the speed of light, is one of the most revolutionary discoveries of the 20th century. This is where teleportation comes in. Using the entanglement principle, physicists have succeeded in teleporting information between particles. Now, it is important to emphasize that we are not talking about teleporting matter in the traditional sense. That is, we are not talking about taking an object and making it appear elsewhere. Rather, it is as if we are copying the proper information of one particle and transferring it to another, erasing the original, the first in this process. This discovery, supported by the effectiveness of demonstrations in the laboratory with particles such as photons, has immense potential. But, as in any scientific advance, questions remain to be answered. For example, how can we harness this knowledge for technological developments? Will this principle be able to apply to larger objects, for example, human beings? Now I might ask, where are we with teleportation? Well, quantum teleportation, although it is still in its infancy, has made great strides in recent years. The first experimental success was in the 1990s. Since then, the distances at which we have been able to teleport information have grown exponentially. To give you an idea, in 2012, a group of researchers managed to teleport information from photons over a distance of as much as 143 kilometers between two islands in the Canary Islands. It is as if we had teleported information from the top of a mountain to its base, overcoming atmospheric obstacles and interference of all kinds. 143 kilometers. In absolute terms, this might seem like an all too ridiculous distance, but when we consider that all this is happening at a subatomic level, where particles are incredibly sensitive to any kind of disturbance, we understand that this is quite a feat. This is a gigantic leap if we compare it with early experiments. However, it is essential to understand that on the net of this progress, many obstacles remain to be overcome. For example, ensuring particle coherence and teleportation accuracy over longer distances. Longer distances, a conundrum that researchers are still working on. The realization of Star Trek-like teleportation may be a long way off, but each small step brings us closer to a deeper understanding of the phenomenon. And who knows, a new discovery may be just around the corner. Now, with all the excitement surrounding quantum teleportation and the advances we have discussed, it is crucial to look at the other side of the coin as well. First of all, the problem of scale remains. Although we have been able to teleport information between particles such as photons, do the same with objects of macroscopic size, such as a human being, but also a single atom, is a much more complex task. The complexity then grows exponentially with the size of the object, making teleportation of larger elements still a distant goal. Then there is the problem of teleportation fidelity. Although we can teleport information, ensuring that this information is transferred without alteration remains an unknown. Any slight variation could have unpredictable consequences, especially if in the future we plan to teleport something more complex than a single particle. Another significant obstacle is the environment. Quantum particles are extremely sensitive to interference. Factors such as radiation, temperature, and even vibration can affect the outcome of teleportation. This means we must find ways to protect and isolate the particles during the process, ensuring that the surrounding environment does not compromise the operation. Last, a fundamental issue that is often debated. Even if we were able to teleport a human being, what would happen to his or her consciousness? Would it be the same person before and after teleportation? These profound questions touch not only physics, but also philosophy, ethics, and theory of mind. It is clear that we face an intricate path, but, as the history of science teaches, obstacles are made to be overcome. Although the challenges are enormous, the promise of teleportation keeps the curiosity and determination of researchers alive. Every small step counts in this field. But let's return for a moment to entertainment and popular culture, which have given so much space to teleportation. Media representation goes well beyond classic science fiction. Teleportation has become a symbol used to tell stories of adventure, danger, innovation, and even existence. Take Harry Potter, for example. Here, the ability to instantly appear and disappear is a highly coveted skill for wizards. Or movies like Jump, where teleportation is used as a means of escape and exploration, but also as a source of conflict. These depictions, though far removed from scientific reality, are a window into our hopes, fears, and aspirations. Teleportation in these stories is not just a means of moving from one point to another. It represents freedom, infinite human potential, and, at times, the complex moral and ethical issues that arise when playing with the laws of nature. Although these stories seem like just a source of entertainment, they have a real impact on the way we perceive and imagine the future. How many times, after watching a movie or reading a book, have you thought about what your life would be like if a particular technology became a reality? These stories feed our curiosity. Also, let's not forget the role of popular culture in inspiring scientific advances. Many researchers admit that they embarked on their careers because they were fascinated by science fiction stories or movies that struck them as children, and so it is only right to pay homage to the stories that made us dream. We have taken an incredible journey through the idea of teleportation, from imagination to quantum mechanics. We saw how teleportation, once confined to the pages of novels, now has roots in reality, thanks to physics, quantum entanglement, experiments, and challenges that await researchers are just some of the points we discovered along the way. If you are interested in learning more about this topic, check out the books I left in the description. If you enjoyed the video, don't forget to subscribe to the channel, share the video with friends, and leave a comment with your thoughts. Your participation spreads knowledge and grows the community.